But that's why I start communicating 6 weeks ago.
No, that's good.
With mass emails like, get in and see me. Here's my office hours. If office hours don't work, call me. If that doesn't work, email me. Send me your grad tracks. If you give me a long plan, I'll clear you for a full year.
Now you're getting all the
I've gotten 5 emails in the last night. What are your office hours again? Click on the link in the email I sent you 3 times. Seriously, I've just started deleting them. Honestly, I've just started deleting them because I'm tired of responding to them. I'm like, seriously. Horse water. Anyway, sorry.
Their parents did everything for them as children.
I didn't say it. I didn't say it, Christine. All right, so let's revisit, friends. Let's revisit Monty Hall. And then we're going to take Monty Hall and go further today. That was the plan. We're going to go to roulette, I think, next week. We'll get this problem going next week, and then we'll end the term by looking at craps and the expectation of a distribution, which doesn't make any sense to you right now, hopefully. But it will make sense by the end of week 10, and that'll take you strongly into 243 if you go to 243. If you don't, it'll take you strongly into understanding your insurance rates a lot more. So, yes, I like ending with this because of that, the idea of expectation. So we need Monty, right? I think this is Monty, and we also need, there you are. Let's make sure we're something recursive. Uh-oh. Did I? Okay, I think it's open. Please, Christina.
Can I just ask on the next project for the Excel?
Yes!
So if you've taken Computers 120, it should be a little bit easier.
It should be a lot easier. I would imagine it would be a ton easier if you've taken 120, because I think a lot of the stuff in there is from 120, but I wrote it to assume you didn't take it. Okay. Yeah, I wrote that the last project.
It's like, oh my gosh, there's so much.
No. The last project is all about how to make basic graphs in Excel. I wrote it as though you've never turned Excel on or done anything in Excel before. Right. So that's how I set the project. The project will be like that. If you've taken 120 or 131, it should be a walk in the park. Easy. Okay. And I have a bunch of tutorial videos as well that accompany a bunch of the problems. So you can always go in there and watch those if you get stuck. So, and I made it myself. Like I actually made them based on the data that I've collected myself. So it's floating if you need it. Oh no, for sure. Good question. So if you remember Monty.
Yeah.
And let's make a deal. Yes. So we had a good time betting for lollipops last time. And I've forgotten exactly. We played about 20 trials before we ran out of time in class. I think about 20 trials. Remember what happened? Well, actually, let me back up. 3 doors. Each of you played the game. I think we had everybody play in the class one time. Yeah. You all picked a door at random. I assigned a door at random with the prize behind, a lollipop behind it. And then you guys picked a door, and then I would open an empty door. And then what would I say to you?
You want to change.
Do you want to stay or switch? And before we did the exercise, about 75% of the class said they thought they should stay with their original choice. The other 25 were split between we should switch or it doesn't matter, which basically means the same thing, I guess, as staying. Actually, I'm not sure what it doesn't matter means. So a chunk of you, maybe an eighth of you said, it doesn't matter what we do because the lollipop's floating around. A couple of you said we should switch. Most of you said we should stay. Okay, so let me go back to that again, turn my ringer off too. Why did you say you should stay? Those of you that voted for stay originally, do you remember why you voted for that? I should have asked you this yesterday when we had you like fresh in your mind. So you pick door number 1. Monty opens 2 and shows you that it's empty. And he says you can switch from 1 to 3 or you can stay with 1. And the vast majority of you said stay with 1 last time. Remember why? What was that feeling as to why? It was just a gut feeling. Was it just gut?
Well, I thought you were tricking us.
Oh! Okay. Why would you think that? Because I'm a bastard?
We don't know you. We don't know how much you know.
You sound like Bassini in The Princess Bride. All I have to do is extrapolate what I've already known from you. Are you the kind of fan that put poison in his own goblet or the one away from him? Clearly you have a Disney intellect. Just watch out for my son for the first time this weekend. Genius. So, I wasn't trying to be tricky. Actually, probability is going to be counterintuitive enough by itself, but I wasn't trying to be tricky. So those, besides Josh, who thinks I'm a bastard, why did the rest of you say stay?
I went with my gut.
Go with the gut. The gut said stay. Christy?
Because there would really be a 50-50 chance if you already opened an empty door.
So now Christy's saying, okay, so if this door's open now and there's nothing behind it, there's 2 doors left, correct? Which means that it's 50-50 because there's 2 doors. Good, I was looking for some kind of a metric like that. Thank you, sister, thank you. Good. Anybody else feeling the same way?
It conserves energy to
To not move?
Yeah, to
Well,
do
you-
it. What's
it's just the hostess, I think, that has to move back and forth. But that's okay. Conserve her energy or his energy.
When
Good.
I used to watch it on TV
Yes.
as a kid. They always won when they switched.
Now, and
It's almost always,
Did
like
you
you
notice that's what happened in class
Yeah.
when we played?
So I always said switch, switch.
What was the same?
It's the same if
Two or
you
three.
stayed in one or if you switched in one.
It was if you switched and won
Yeah.
and stayed and lost.
Yeah.
Those were the numbers that
Yeah.
were the same last time.
Yeah.
And who noticed that? Josh, did you notice that? Somebody noticed that yesterday. There was a correlation. Maybe it's you, Des. I don't remember now. But there was definitely, and honestly, after 20 trials, I've never seen the data like that before. Usually after 20 trials, there's the same number in each of the 4 categories. Stayed in one, stayed and lost, switched in one, switched and lost. But with you guys, more than half of the trials were either switched and won or stayed and lost. And somebody noticed, I forget who it is, I'm gonna give Josh credit until somebody else stands up, that switched and won is the same as stayed and lost. It's just that you made the wrong choice, right?
Right.
Because if you stayed and lost, you should have switched and you would have won. Does that make sense?
Yeah.
Think about it this way. If that doesn't make sense, he opens door number 2, so you know the prize isn't there. So the prize is either here or here. If you switch from here over to here and you win, that means the prize was here, yes?
Yeah.
But if you stay here and lose, that means the prize was over here.
Yeah.
So it's the same situation.
Yeah.
Good, good. So can we rectify that dichotomy between 50-50 and maybe we should switch? Because that ain't 50-50 anymore, is it? Especially with your memory, Christina, saying that when I used to watch the show, it seemed like those who switch used to win more. Can we bridge that gap between 50-50? Because 50-50 is definitely not switching makes you win more. It would mean switching would make you win half the time. Anybody want to take a stab at it?
66?
What about 66? Tell me. What's that? What's that?
Because that would be 2 of them, so be 33.
Oh, now what Ashley's doing is she's saying, I don't like Christie's 50-50. I think there are still 3 doors to talk about. See what Ashley's saying? There's 3 doors, not 2. But there are 2, aren't there? No, keep going, Ashley, keep going. Talk to me.
That's all I know.
That's all I got so far?
That's all I have.
Let me share something with you guys as I splash coffee on my nose. Let me share something with you. I built this a while ago. It's not very fancy pants. It's kind of straightforward. What this is called, and you'll see a lot of these in 243 and 244 with me. This is the way a lot of statistics is done these days. It's called a Monte Carlo simulation. It's called Monte Carlo because Monte Carlo is a famous casino in, I believe it's Europe. I think so.
Yeah.
And what this does essentially is it mimics a real event by assigning probabilities to something like a spreadsheet. It's the same way flight simulators work for pilots. When you train a pilot, you don't put the pilot in a plane and put him up in the air and say, good luck! It's very expensive, very dangerous. Yes, what you do is you stick them in a simulator for hundreds of hours until they can fly the simulator correctly. Then you have to ask yourself, what's in that flight simulator? What's in that flight simulator? When that pilot pulls in there, what does she have to deal with? She buckles in, right? Probably sits just like this, right?
Probably.
Crotch forward. Go, Amy.
Maybe extremes. Maybe.
Good. Maybe the extremes with the frequency at which the extremes happen. Very, very good. Now, how do we know that? How do we know? Let's define extreme. It's all based on probability.
Crash.
Yes, you crash. You're going to have this engine fail 1 in 1,000 times. So 1 every 1,000 times you fly, you're going to deal with an engine failure. Now, when? I don't know. But on average, 1 every 1,000 times. It might happen twice in a row. You've seen, hang on. You've seen Apollo 13.
Yep.
When, what's the dude's name? Not Tom Hanks. The dude that was supposed to have been sick but wasn't.
Kevin Bacon.
Not Kevin Bacon. He went up in space.
Lieutenant Dan?
Who?
Lieutenant Dan? I can't remember.
Lieutenant Dan! Exactly, Lieutenant Dan. What's his name? He's such a great actor.
Gary Sinise.
Gary Sinise! Thank you. They put Gary Sinise, Lieutenant Dan. Lieutenant Diane. They put him in the simulator to figure out, and then they threw random, yes, the perfect power usage based on the batteries left up there in Apollo 13. And they were throwing, the dudes outside were using computers to throw little random scenarios at them. they never knew when the random scenarios were coming. This also happened before they went to space in the movie, when they were training Kevin Bacon, right? Because they had to train him as well, because he was a substitute, is that correct?
Correct.
Yeah, so they had to train him, and they kept throwing him in the simulator. Now, let's go back and do it again, let's go back and do it again, try with a new random set. All those little conditions are based on randomness, just like anything you do over the course of a day. You drove here today. It was not the same experience as yesterday. There were certain things that were similar, but there were definitely things that were different. That truck coming down at me off of 9th Street. If I had left 5 minutes before or 5 minutes later, or 5 seconds before, even 5 seconds later, I wouldn't have to deal with it at all. But it's just the randomness of all those events of that dude's day and my day came together in that. It's a simulation, except it's real in that case. What this does is it simulates the game you guys played yesterday. So take a look at what it does. First of all, this keeps track of how many games we played. You guys played 20. It's going to keep track of this. It's going to increment 1. Every time I press the F9 button, it's going to increment by 1. Right here, prize is behind. Watch the command I use there. Right there, there's a command called rand between. You guys have used one here called rand int on your TI. It's the same exact command in Excel, just a different language. Rand between 1, 3, which means it picks a random number from 1 to 3. And it puts the prize there. There's no prize. It's a number. It's a simple number. And that's where the prize is. The prize is 1, the prize is 2, the prize is 3. You choose. Now this is where we remove the bias, right here. I use the exact same command. So you randomly pick a door. It's hard to say if you guys were picking doors randomly yesterday. It's hard to say, right? I could test it. I didn't do this, I should have done this. I should have written down every door you guys picked in order that you picked them, one by one, and then put them on the board and see if we thought they were random or not. My gut feeling is that they weren't very random. Because we're not random creatures, we're humans, which is kind of like the antithesis of randomness. You act randomly, you die very quickly, right? If you act, I'm just gonna walk into the, I walk down the street. You know, that's not a good idea most of the time, but it's pretty random. So this is forcing us to be random. Now, this is my favorite command in the entire spreadsheet. Which door does Monty show you? Now, we talked about this a little bit yesterday. Actually, who asked me about that yesterday? Somebody asked me about the door I was showing you. Josh, was that you? I keep giving you credit for all this stuff because I'm looking over there. Maybe it was Jury. It was somebody over here. Somebody over here. I would always open a door and show you a blank door, yes? Now, sometimes I have no choice. For example, back to the spreadsheet, suppose we knew the prize is there, and you pick door number 1. I have to show number 2, don't I? I can't open your door, then the surprise is over. And I can't open door 3 saying, "Ah, there's a prize, sorry, you lose." No, to keep the game going, I have to show you an open door. Does that make sense? But suppose the door was behind door number 3, and you chose door number 3. Was that a yawn combined with a statement? That was wonderful. I love that. Then what? Well, you win if you stay. But what door do I open if I'm Monty?
1 or 2.
Ha! 1 or 2. So, if you look at the command for that, this was one of my favorite things ever mathematically. I had to design a function to randomly pick one of those doors in that case. Now, it looks a little bit weird, but it says if C4 does not equal C5. If C4 does not equal C5. So if what the door is behind is different than the door you have picked. That's the case where the prize is behind 3 and you pick 1. Well, I have to pick the last number, right? And that's actually not too hard mathematically. I just do 6 minus the sum of the other 2 doors. So, if you picked 1, the prize was behind 3. What's 1 plus 3? 4. 6 minus 4?
2.
2. Sorry. If you pick 1, and the prize is behind 2, what's 1 plus 2?
3.
Which door do I show you? 3. 6 minus 3 is 3. See what I'm getting at here? If you pick 2, and the door is behind 3, what's 2 plus 3?
5.
6 minus 5 is?
1.
I show you 1. You see how that works?
Yeah.
Very straightforward. A little bit out. It's something you learned back in Algebra Math 60. You've forgotten it since then.
Totally.
It's totally fine. But you see how it works. Now, that's the easy part. The hard part is, if not, then I have to make up a conditional. This is one of my favorite things I've ever done in mathematics. Remember when you learned the quadratic formula? I had to use it to solve this problem. I was so stoked. You don't look as stoked as I was so tickled when I sat down to figure it out because I had to randomly generate I had to randomly generate, and there's an if there. If A6, which you cannot see, there's a little,
It's there.
A6.
It's just
You
a
can
tiny
see it?
little column,
It's
yeah.
right there, but you can't see it. I must have a random number tucked in there. Hang on. Yep, right there. I got a random number tucked in there, 1 and 2. That flips a coin for me and tells me which door to pick. And then I have to tell the Excel what number to use, and that's the command that was tucked up in that cell.
That's pretty impressive,
It's
Sean.
fun as, oh man. I love Excel. If I could teach an entire course on Excel, like
You
probability
should,
with
because
Excel.
the people that teach it here are not good.
No, not Excel, but probability with Excel.
Oh, yeah.
I could teach an entire course on, every year I go to the Wormatic Math Conference for all the community colleges, and I do a 2-hour talk on the stuff I've invented since last year for simulation. There's always 25 people that are in the room, and that's the problem. There's only 25 people that care.
Right.
There's only 25 nerds.
There's only 25 nerds in the entire state of Oregon that care, and then our community college students. I wonder how popular this would be, or what I give you credit for. That's the problem. There's not enough geeks. We need more geeks.
We need good computers.
We need more Uber geeks. Anyway, switching. Should we switch or not? I made that random too. I assigned a random number over here, ran between 0 and 1. I said if it's 1, yes, you switch. If it's 0, no, you don't. A coin flip, again. I don't know why I use 0, 1 there, or 1, 2 above. It doesn't matter. It's the same thing. Flipping a coin, heads and tails. That's how you decide whether you switch or not. And again, I'm not sure you guys were thinking about that yesterday, because we had that great dichotomy. I'm not sure that you were thinking about that. The results, fairly straightforward, fairly straightforward. The A8 cell is the result of all of that. That gives you a conditional to keep track. If you switched and the prize was not behind the original door, then you won, otherwise you didn't. Fair enough? It's all just a sequence. Basically, I'm using Excel to sequence what you guys did one by one in class. Except I'm making it even better because it's being purely random on how it chooses a door and whether it stays or switches. So every time I press F9, here we go, you ready? F9. Okay, I need to make this a little bit
You
bigger.
lose.
Well, you lost that one because you chose 2, Monty shows you 3, the prize was actually behind 1. If you don't switch, you picked the wrong door, so you lost that round. Does that make sense? The prize was behind 1, you chose 2, and you didn't switch. That means you lost. It's just straightforward, right? Now, getting Excel to calculate that is the trick, but understanding it's not. You picked the wrong door, and you stayed with your wrong choice. Is that fair?
Yep.
Okay, let's play again. You picked this time door number 3, and the door leaves you behind 1, and you didn't switch again. How about again? You picked 1, the door's behind 3, and you didn't switch. So let's go ahead and hold down the F9 button for a little while. What we're doing right now is playing, we're up to 150 games. See if you can see any patterns showing up in the numbers. See if you can see 50-50, 66, 33, hike. I heard a you should switch somewhere.
Oh, right there.
They're
It's like
really
the opposite.
close.
They're the
Yeah, I would
opposite.
say
Oh, wait a minute. Now we figured that out yesterday. The oppositeness is we figured that out yesterday. I'm going to hold this down. Hang on one second. I want to come over here. The stapler will hold. Oh, it didn't hold. Hang on. There it goes. Now, did you notice how noisy? Did you notice how noisy? There they go. How noisy it was in the beginning. The numbers were jumping all over the place. And now they've begun to stabilize. They're not perfect. They will flutter every once in a while. But they're beginning to stabilize. And Amy, what did you say about something being equal?
Well, they're 60-30, roughly.
Right.
They're like 2/3, like she said.
They're 2/3, 1/3. They are heading to 2/3 and 1/3. And now somebody also noticed that this one looks like that one,
Yeah.
Right.
and that one looks like that one. You guys figured that out before you left yesterday. They are the same. Because if you switch and win, that's the good result of switching and winning. That's the same thing as staying and losing. Does that make sense? Switching and winning means you picked the wrong door first, and you switched and got the right one then. Staying and losing means you didn't switch and you stayed with the wrong one. In much the same way, switching and losing would be the same thing as staying and winning. Because if you were on the right door to start, right, and you switched off of it, that means you would have lost. But it looks like that doesn't happen quite as often. It looks like switching off the right door only happens 1/3 of the time, whereas switching off the wrong door happens 2/3 of the time. That's what I'm seeing anyway. Oh, look at that now.
Even.
67, 33, 33, 67. Hike!
Oh,
Explain to me why. Ashley, let's go. You had the 66, didn't you? No. What told you that?
Because there's only like one chance that they're gonna pick the wrong door, so like.
Yeah. Think about this. When Monty starts, I think we're getting the point. It's still playing. It's still playing, but it's not it's asymptotically now come in at the probabilities, and it's not going to fluctuate very far from there. Good. You get the point. Excellent. Let me go back to this. So let me ask you guys a very simple question. Actually, go with that again. When you pick your first door, there's only one prize and 2 blank doors. 3 doors total, right? So, please.
I was gonna say that if there were 2 prizes, the statistics would be switched.
Different story, right? Different story. But since there's only one prize, what's the chance you get the door right on your first pick? 1 in 3. When he shows you a door, he doesn't move the prize. The prize still stays where it was, right? You didn't see me move the lollipop. I didn't change the lollipop position, right? Now, if I did, Christy, if I had changed the lollipop, then it becomes 50-50, because then you have no prior knowledge. But what you have to realize is when that game starts, you probably picked the wrong door. It's 1 to 3, 2 to 3 against, or 2 to 1 against, I guess. There's a 2/3 chance you picked the wrong door. So actually, when Monty takes a door away from you, he's actually doing you a favor, isn't he? He knows, and now you do too. If you're who hosts the show? Does Wayne Brady? Drew Carey. This show is still hosted, isn't it?
Yeah, it's Wayne Brady.
He's Price is right. It's Wayne Brady.
Wayne Brady,
So when you're up there with Wayne, and he gives this to you, what are you going to do?
Switch.
You should switch because you stay.
No, I said switch.
Oh, you said switch. I thought I heard
I screwed it
stay.
up. No, I said switch.
Like Ashley, how could you? In the heart. Oh, switch. Got it. I wasn't expecting a long eye sound. Right in the heart. The idea is by showing you a door, he's actually doing you a favor. Because he's saying, essentially think of it this way. The prize is 1/3 here, 1/3 here, and 1/3 here. When he takes that away, that extra 1/3 gets swapped to the other door you didn't pick. It has to. It has to go somewhere. It has to go somewhere. Now, I want to revisit why it doesn't get split evenly, because that's what Christy was talking about. So see, if you don't buy this, see if you buy this analysis. Nope, there it is right there. Here's all the possible scenarios that can happen if you pick a door and stay with that same door. This is all the possible scenarios. This is why I had you do that project, to get this kind of idea. There should be 9 possibilities, because you can pick any of 3 doors, and the prize could be behind any of 3 doors, so there are 9 total possibilities. If you stay with the door, if you pick door number 1, and the prize is behind door number 1, you won. Clearly. If you pick door number 2, and the prize is behind door number 2, you won. If you pick door number 3, and the prize is behind door number 3, you won! Yay, those are all the wins! The problem is, there's 6 loses in that scenario, right? Because if you pick door number 1, and the prize is behind door number 2, you've lost, because you chose to stay in this scenario, right? Same thing goes if you pick door number 1 and the prize is behind door number 3. So you're seeing the 1 and 3 come up right now in every column. For every door you pick, there's 1 way you're right and 2 ways you're wrong. That gives you a percentage, if you will, of being right of, where did it go? There was a 1/3 up there, I can't, there it is. The percent, or the fraction of the time you win if you stay is just that 1 in 3. Because you're only going to win if you pick the door the prize is behind, but you only get that 1 in 3 times. Does that make sense? What happens if you choose to switch? All of the wins become loses, but all the loses become right. Let's take a look at it.
so you have a 2/3.
Yes! All because you switched. Now remember, this one was a win, but there were 2 loses with that win in the previous slide. But if you switch, that means you're going to win in both of those that used to be loses. So everything that was a loss becomes a win. And since there were more losses in the previous scenario, this strategy gets you more wins. It's not a guarantee, of course. It's not a guarantee, right? It's not a guarantee. It's a probability.
I got a lollipop when I stayed.
Well, that's because I care about lollipop. Whether you, oh, that's right. That's why I said that. It's not a guarantee that you're going to lose if you stay, but you win twice as much as you lose if you switch. Does that make sense? Is that believable? Is that fair?
Like I said,
That's okay. I love that you brought that. I brought that up at 2:43, and the kids were like, "That's pretty freaking cool." I'm like, "It is pretty freaking cool, actually." Using past knowledge or past behavior to
Even though I
predict.
was only like the second one, but.
No, and that's cool though. But here's the deal, right? Replicate that experiment thousands of times and see if your strategy works. So in other words, do something like this. We can do a real quick one for you if you want. We'll just make a new sheet here. And let's just do equals rand between, there we go, 1, 3. Okay, and then drag that bad boy this way a bunch of times, right? Okay, they're all 3s. Why is it doing that? Because this is set wrong. Hang on one second. Options, formulas, check automatic. Thank you. There they go. So now, Des, we can check that. Look at each number and then check whether the number right here is the same or different. So we can set up a command for that. Okay, you ready? Equals if this equals that, type yes. Otherwise, type no. Okay, then we drag that over a bunch. And then you ask yourself, how many yeses versus nos do you see? Right, see, this is where it gets fun. This is where simulations can answer questions almost immediately. You ever heard of Nate Silver, political analyst? He's the only one that does a good job predicting polls. The only one that does a good job predicting polls. You know why? Because he does this. He takes all his data in and develops simulations. This is how they predict weather. Are you guys ever amazed at how well the weather's predicted in this town?
It's not.
Seriously, it's awesome.
It just seems.
You got to compare
remember.
weather predicted in this town to weather predicted in any other town. Now, I've lived in a bunch of places.
Yeah.
They suck.
Yeah.
And you have to realize, too, they're dealing here with the mountains
Right.
that make everything more challenging. And we're dealing with microclimates.
Microclimates, yeah.
We are 500 feet up. My commute every day, I picked up more elevation than my home state used to have. Delaware only goes 400 feet above sea level. I come up 500 feet from 3,200 to 3,700 every day. That is incredible, and they do a pretty damn good job. Why? They're running simulations constantly. You ever see the hurricane tracks and the typhoon tracks and the tsunami tracks? When they show those arcs and they say, hurt, those are all based on simulations. This is how stuff is done these days. So, Des, that's how we can check, right? Then you have to ask yourself, what do you think? Are you seeing more yeses or nos? Right? That's the trick, right? I can predict, without even running the numbers, you're going to see 2/3 no's and 1/3 yes. Because that's what 1/3 probability means. We'll come back to that after the break. But thank you. Thank you. I love that you were thinking that way. It makes me so happy. The trick about that random clumping thing, and I want to say this again, because especially because you brought that up, which is so awesome. Random clumping is something that you check after the fact versus trying to predict what's going to happen next. When you try to do it to predict what's happened next, you're still at the whim of randomness. Think of that coin flipping, right? That coin flipping 12 times. You would have thought something was weird at 8. And then at 9, you're like, it's like that guy on the Powerball commercial. I tell you that one, right? The Powerball commercial from years ago? No, you haven't? Okay. I'm going to make a quiz about this one. But there's a dude, it's a commercial for Powerball. You know what Powerball is? Yeah. Pick 6 numbers. And there's a dude sitting with a bunch of his friends. They're playing cards, I think. And there's a TV on next to him. This is back when little black and white TVs were popular. So 1862 or something like that. And you hear, and welcome to Powerball! And the guy's like, oh, I got a ticket. And he pulls the ticket out of his pocket. They're playing poker. They're not interested at all. And then they pulls the number. He's like, hey, guys, I got 1. And people at the table like, oh, whatever, you got 1 number, whatever. He's like, hey, I got 2. And then one girl's head turns around. I got 3. All of a sudden, the whole table turns around. You got 3. And he goes, 4! And then the whole table gets around him. And then the commercial ends. It's genius marketing. I started with this commercial from like 30 years ago. He goes, 5! And then the commercial cuts. And it's genius. And I'm like, guess what? You probably didn't get 6. You probably didn't get 6. This is only a 1 in 35 chance if you did. Right? But that's the thing. Genius marketing. Because they play on that lack of understanding that we have. We think there's then momentum, don't we? We think there's momentum.
That's what happens at craps tables, too.
Oh God, craps. That's why we're going to analyze craps in here. That's why we're going to analyze craps in here, to see those little runs, to see those hot streaks.
Right.
So we can, the little old lady, when her machine is due, we can kick her off her stool and lose all our money. But that's the thing, marketers, one of my favorite commercials I've ever seen in my life, because it just played the human condition so well, and ignored the math so subtly. 5! Boom! And then it was like, will you be next? I'm like, no, probably not. But that doesn't matter, because the marketing was done like 30 years later. I still remember that commercial. Like, think about that. How many commercials will you remember in 30 years? I'll remember the Darth Vader commercial for Volkswagen. Remember that one? The little boy with the Force. I'll never forget that commercial. But that's
Oh,
like,
that's my favorite.
it's such a good one.
It's so cute.
It's such a cute one. But like, how many others do we remember? The Powerball commercial, the Darth Vader commercial.
Mikey likes it.
The lifesaver
Yeah, I remember
commercial,
Mike.
where the little boy says, do it again, Daddy.